Every day, over 13 million bags of Doritos are consumed worldwide. Their irresistible crunch, that delicious cheese dust, and their addictive flavor make them one of the most popular snacks on the planet. But have you ever wondered how they're actually made? What makes them so addictive? Well, today we're traveling to Georgia, United States, home to the largest Doritos factory in the world, where over 10 tons of chips are produced daily, ready to be packaged, distributed, and devoured. So get ready, because today you'll discover how Doritos are mass-produced. Let's begin. Step number 1. Corn harvesting. It all starts in the enormous cornfields. A single hectare of these crops can hold over 60,000 plants, and each one can produce between 1 and 2 cobs full of kernels ready to become chips. Doritos works exclusively with certified suppliers who cultivate a special variety of corn with just the right level of starch, moisture, and hardness. This ensures a firm dough, a perfect crunch, and consistent flavor batch after batch. When the corn reaches its optimal point of maturity, the harvest begins. Enormous automated harvesters speed through the fields, collecting cob by cob without stopping. These machines separate the kernels in real time and deposit them directly into internal compartments, saving hours of manual labor. In just 1 hour of work, these harvesters can collect over 20 tons of corn, moving through the fields with pinpoint efficiency. When full, they unload their contents into gigantic cargo trucks, which will transport the tons of freshly harvested corn directly to the factory, where the real transformation process will begin. Step number 2. Arrival at the factory and dough. Preparation. Once the trucks arrive at the factory, the intense work begins. Each unit unloads tons of freshly harvested corn into enormous stainless steel silos, where the grain starts its transformation. First, it undergoes an industrial cleaning process. Powerful air, vibration, and filtering systems remove any remaining cob, dust, stones, or impurities that came from the field. The goal is to leave the grain completely clean and ready for cooking. Next comes nixtamalization, a millennial process adapted to industrial scale. Here, the corn is cooked in giant tanks with hot water and lime, which softens the grain, enhances its flavor, facilitates grinding, and improves its nutritional value. Once cooked, it's rinsed again and transferred to industrial mills, where it's ground into a thick, uniform, and lump-free dough. This step is crucial. If the dough is too dry, the chips break. If it's too wet, they don't fry well. That's why smart sensors and expert operators control the temperature, humidity, and texture in real time. With the dough at its exact point, it's time to shape thousands of Doritos. Step number 3. Shaping the chips. With the dough prepared, one of the most satisfying steps of the process begins: shaping the Doritos. The dough is spread onto a conveyor belt as a continuous, thin, and perfectly leveled sheet. This sheet moves non-stop towards a giant rotary cutter, equipped with triangular stainless steel molds. Each mold cuts the dough with surgical precision, generating thousands of triangles per minute. The size of each chip is calculated to the millimeter, 5 centimeters per side and an average thickness of 1.2 millimeters. Everything is designed so they fit in your mouth, don't break when dipped in salsa, and create that characteristic crunch with every bite. The machines work at full speed, over 6,000 chips per minute, aligned one after another as if they were mass-produced pieces. Once cut, the raw triangles pass to a conveyor belt that will take them directly to the cooking area. Although they already have their shape, they still lack color, flavor, or texture. They are just raw dough triangles. So now it's time to bring each chip to life and turn them into the Doritos we all know. Step number 4. Baking and frying. Now that the chips are shaped, it's time to turn them into something edible, crunchy, and golden. First, the triangles pass through an industrial oven at over 300 degrees Celsius, where they bake for a few minutes. This initial baking doesn't brown them or add flavor, but it does remove internal moisture, harden their structure, and prepare them to withstand hot oil without breaking or bending. After leaving the oven, the chips go directly to the frying area, a conveyor belt that submerges them for a few seconds in a pool of hot vegetable oil. This is where the magic happens. The Doritos slightly puff up, brown uniformly, and develop their ultra-crispy texture. The sound, the resistance, and the bite are all defined at that moment. The oil is constantly filtered and replenished to maintain its purity and prevent strange flavors. Once fried, the chips ascend inclined belts that allow excess oil to drain completely. Now that they are perfectly fried and ultra crispy, the most important step of all arrives, adding the flavor that makes them irresistible. Step number 5, flavoring. We've reached the most anticipated step, adding the flavor that makes them unique and addictive. The Doritos pass through enormous rotating drums that act like a sort of snack washing machine, but with seasonings. Inside these drums, a fine mist of flavoring powder completely covers each chip as they gently tumble to ensure the seasoning adheres evenly. Each flavor has its secret formula, developed by food technologists in specialized laboratories. The classic cheese, the explosive flamin' hot, the irresistible barbecue, and hundreds more variations that change depending on the country. The blend is precisely calibrated to achieve the exact balance of salt, acidity, spice, and sweetness. And it's no accident that the powder stays on your fingers. According to Frito-Lay studies, that sensation increases the consumer's emotional connection with the product and makes them want more. There are even systems that verify the amount of flavor applied per batch, so every bag has the same flavor intensity, regardless of whether you buy it in Mexico, the United States, or Japan. With their shape, crunch, and flavor, Doritos are practically ready. But before they reach your hands, they still have to pass one last test. Step number 6, inspection and quality control. Even though they're already fried, seasoned, and ready, Doritos still can't be packaged. First, they have to pass through one of the most demanding filters in the entire process, quality control. The chips zoom along conveyor belts while a system of high-resolution cameras and optical sensors analyzes each Dorito, one by one, searching for any defects. If anything doesn't meet the standards, it's automatically ejected from the line and sent for recycling. But it's not all automatic. Expert operators take random samples from each batch and evaluate color, texture, thickness, aroma, and even the sound when broken. Only the Doritos that pass all these tests continue their journey. The others never make it into the bag. And now that they've been approved, it's time to seal them, package them, and send them out into the world. Step number 7, packaging and distribution. Once quality control is passed, the Doritos are finally ready to be packaged. The approved chips slide down metal hoppers into automatic packaging machines that run non-stop. Each bag is filled with the exact amount of product injected with nitrogen to preserve the crunch and vacuum sealed in milliseconds. Then, the bags are labeled, grouped into boxes, and loaded onto refrigerated trucks. From there, they travel to supermarkets, gas stations, stores, stadiums, and vending machines worldwide. And what's most impressive? Less than 30 minutes can pass from the time the corn enters the factory until the Dorito is packaged. Everything is timed to the second so the product arrives fresh, perfect, and with just the right flavor. And that's how a simple corn kernel transforms into one of the most famous snacks on the planet. To finish, tell us, were you surprised by the Doritos manufacturing process? What's your favorite flavor? Leave your answer in the comments. And if the process surprises you, give us a like, subscribe, and hit the bell so you don't miss our next factory tours. Every day, more than 400 million M&Ms are consumed worldwide. Their striking color, that crunchy sugar shell, and their delicious chocolate interior make them one of the most popular candies in history. But have you ever wondered how they are actually made? What makes every M&M so perfect and so addictive? Well, today we will travel to New Jersey, United States, home to the largest M&M's factory on the planet. A place where more than 40 tons of chocolate and sugar are transformed daily into millions of small spheres ready to conquer palates around the world. So get ready because you are about to discover how M&Ms are mass-produced. Let's begin. Step 1. The birth of chocolate. It all begins in the enormous cocoa plantations located in the tropical regions of Africa and South America. The company works exclusively with certified suppliers to ensure a cocoa with the exact balance of aroma, acidity, and fat needed to achieve the candy's unmistakable flavor. When the cocoa pods reach their optimal point of maturity, the harvest begins. Thousands of farmers cut each pod by hand and extract the fresh seeds, which immediately undergo the fermentation process. For 7 days, the tons of beans rest in large wooden boxes, reaching temperatures close to 50 degrees. This is where the first great transformation occurs. The heat causes natural reactions that completely change their flavor and aroma, turning them into the intense, unmistakable cocoa that will later give life to the heart of every M&M. After fermentation, the beans are spread under the tropical sun to dry for several days, reducing their moisture to ideal levels for transport. Once ready, they are packed into large jute sacks that travel by truck and ship to the processing plants, where the real magic will begin, transforming simple cocoa beans into the chocolate base of every M&M. Step 2. Arrival at the factory and creation of pure chocolate. Once the sacks of cocoa arrive at the plant, mass industrial work begins. The tons of beans are unloaded into enormous stainless steel silos and immediately go through a cleaning process where air jets, controlled vibrations, and filters eliminate dust, shells, and any impurity. Next comes one of the most decisive phases: roasting. The beans travel through giant ovens that reach up to 150 degrees Celsius, and under this extreme heat, they not only acquire the characteristic dark color of chocolate, but also release an intense aroma that permeates the entire plant. After leaving the oven, the beans pass through crushing mills that break the shell and expose the internal nib. This nib is ground into a thick paste called cocoa liquor, the purest base of the chocolate. At this point, the liquor is introduced into enormous industrial mixers, and operators incorporate the exact proportion of sugar, milk powder, and cocoa butter, giving rise to the unique formula that distinguishes M&Ms. Finally, the chocolate enters the conching process, where huge steel cylinders stir it for hours. This refines its texture, removes bitter notes, and enhances that intense, unmistakable cocoa flavor. The result is a shiny, uniform, and silky chocolate. Step 3. Core molding. With the liquid chocolate prepared, one of the most impressive moments of the entire production begins. The tempered chocolate flows through millimeter-calibrated dosing nozzles that drop thousands of exact droplets onto refrigerated metal bands. In a matter of seconds, each droplet solidifies to become a perfect and uniform sphere. The machines work with surgical precision. Every sphere must have the same weight, diameter, and density. A minimal deviation would be enough to ruin millions of pieces. The pace here is enormous. In a single production line, more than 2 million cores can be formed per hour, aligned in endless rows. At this point, however, they still have no color, no characteristic hardness, and no iconic M. They are just pure chocolate hearts waiting to receive their definitive armor, the legendary crunchy sugar shell. Step 4. The sugar shell. The millions of chocolate spheres enter enormous rotating drums known as panners. There, while spinning relentlessly, a thin layer of water and sugar syrup is sprayed onto them in ultra-thin layers. Each layer is dried before the next one is applied, and this process is repeated dozens of times to form a hard and perfectly uniform shell. This is where M&Ms acquire their unique resistance. They don't melt in your hand, but they do melt in your mouth. The sugar shell was originally designed during World War II so that soldiers could carry chocolate in combat without it melting in the sun or their pockets. What began as a military innovation ended up becoming one of the most famous snacks on the planet. At the end of this step, the M&Ms are still uncolored, small, crunchy, and resistant white spheres. Step 5. The color burst and the final seal. Here begins the transformation that turns simple chocolate balls into the M&Ms we all know. Millions of spheres enter huge rotating drums again, but this time they receive baths of safe and perfectly measured food colorings. Each drum is dedicated to a distinct color: red, yellow, green, blue, orange, or brown. Precision machines control every step to ensure the perfect statistical blend of each color in millions of packages. Next, a thin layer of edible wax is applied to intensify the shine and protect the pieces. And right here comes the most famous touch: the letter M. In a high-speed line, the M&Ms are automatically aligned, and a precision printing system applies the letter with edible ink in fractions of a second. A curious detail is that not all of them are printed with the M. Around 20% are intentionally left unmarked. Step 6. Extreme quality. Control. With the color and the mythical letter M printed, the M&Ms must still pass the most demanding examination in the entire plant: quality control. Here, every chocolate piece must be perfect, or it will be eliminated without mercy. The millions of pieces speed down conveyor belts while high-precision cameras and sensors analyze shine, color, uniformity, and the exact definition of the M. These systems are so fast that they check hundreds of thousands of units per minute, detecting defects impossible for the human eye to see. After this first filter, physical tests arrive. Randomly selected batches are subjected to checks for hardness, coating thickness, and color resistance. Finally, human judgment comes into play. Specialized tasters sample batches to confirm that the flavor, aroma, and crunch are exactly what millions of consumers expect worldwide. Only those that pass 100% of the tests continue on the line. Step 7. Packaging and distribution. In enormous automated lines, thousands of pieces per second fall into precision hoppers that dose the exact amount of candy into each bag. Ultra-fast sensors verify the weight and quantity in real time. Before sealing, each bag receives an injection of nitrogen to keep the sugar's shine, the chocolate's freshness, and that perfect crunch intact. In fractions of a second, the packaging is heat-sealed. Finally, the bags are grouped into boxes and loaded onto giant pallets, beginning a worldwide journey to more than 100 countries. Amazingly, M&Ms haven't only traveled on Earth, they have also been to space. Since 1981, NASA has included them in its missions because they are easy to transport, do not melt, and do not create crumbs that could float in zero gravity, literally making them little chocolate astronauts. Thus, what started as a simple bitter seed on a tropical tree ends up transformed into one of the most famous and consumed candies on the planet. To conclude, tell us, did you imagine this entire process? What is your favorite color when you open a bag? More than 100 million Oreo cookies are consumed every day around the world. They are addictive, irresistible, and have become the best-selling snack on the planet. But have you ever wondered how they are actually produced? What ingredients are hidden inside? Well, today we'll travel to the United States, home of Mondelez International, the largest Oreo factory on the planet, where more than 1 million cookies are produced every hour, ready to be distributed and devoured in more than 100 countries. So get ready, because today you are going to discover how Oreo cookies are mass-produced. Let's begin. Step 1. Preparing the dough. It all begins with the most important element for producing Oreos, the cookie dough. At the Mondelez plants, huge trucks arrive every day loaded with tons of the main ingredients: refined wheat flour, crystalline sugar, and high-purity cocoa powder. Along with them, corn syrup, vegetable fat, and salt are also unloaded. Although they may seem simple, these 6 ingredients are the exact formula that gives life to one of the most famous cookies on the planet. With the help of operators and automated systems, each raw material travels from the silos and tanks to the mixing room, where gigantic stainless steel mixers await, ready for action. There, each ingredient is poured in quantities calculated to the millimeter, and immediately afterward, the enormous metal blades begin to turn with force. In a matter of minutes, what were loose powders and liquids are integrated until they become a thick, uniform, dark brown dough, releasing an intense cocoa aroma that fills the entire production plant. A single one of these mixers can produce more than 500 kilograms of dough per hour, a sufficient amount to make more than 100,000 Oreo cookies in a single shift. That's a truly impressive number. And with the dough ready, it's time to shape it into cookies and create thousands of Oreos. Step 2. Forming and stamping the cookie. We've arrived at one of the most critical steps in the entire process. At Oreo, everything is designed to the millimeter, so that in the end, each cookie always has the same size, thickness, and that unmistakable crunch in every bite. So precision is crucial here. The dark, dense dough moves along long conveyor belts until it reaches the automatic dividers, equipped with high-precision blades that cut it into smaller uniform portions, ready for the molding that will come later. Once portioned, these pieces pass to the roller molders, which serve a dual function. First, they flatten the dough and, at the same time, give it the exact shape of the cookie, forming thousands of identical discs in a matter of seconds. And here's the most interesting part. At that same moment, an industrial stamping system imprints a relief on each piece, made up of geometric figures, and the name Oreo engraved in the center, which is repeated identically on all the cookies in the factory. This design isn't just decorative. The relief helps the cookie maintain its perfect shape during baking, and gives it that unmistakable crunchy texture that everyone recognizes on the first bite. This entire process happens at an impressive speed. What was a shapeless dough is transformed into thousands of dark, raw, perfectly circular discs with the most famous design in the cookie market. Step 3. Perfect baking. With the discs now formed and stamped, the process that will define the Oreo's unique texture begins. The raw cookies move in long rows on steel conveyor belts that introduce them into huge industrial tunnel ovens. As they travel inside, these ovens reach temperatures of over 200 degrees Celsius. And in just a few minutes, each cookie receives the exact dose of heat necessary for the moisture to evaporate and for the dough to acquire the perfect hardness and crunch. In turn, a team of sensors and automated control systems monitors the temperature, humidity, and belt speed in real time to ensure that millions of cookies come out identically baked. A minimal error at this point could ruin an entire production. Soft cookies that break at a touch, or burned discs that are impossible to consume. Upon leaving the oven, all the discs go through controlled cooling tunnels, where powerful industrial fans and cold air jets gradually reduce their temperature. Precision here is vital. If they cool too quickly, the cookie can crack. If they do so too slowly, it loses that crunchy texture that makes it unique. If everything goes well, the final result is thousands of perfectly baked cookies ready to receive the star ingredient. Step 4. Preparing the cream filling. While the cookies provide the crunch, the white cream is the soul of the Oreo. That sweet, smooth filling, which contrasts perfectly with the intense cocoa flavor, is, for many, the best part of these cookies. Many fans even confess to eating the cream first and then the cookie, creating their own ritual with each Oreo. In a separate room of the plant, gigantic stainless steel tanks receive the basic ingredients to create this cream: ultrafine powdered sugar, refined vegetable fat, corn syrup, and vanilla essence. All of these are poured into high-power mixers where huge paddles spin at high speed until they form a white, homogeneous, and silky mixture. The texture must be perfect, firm enough to hold the two cookies together, but soft enough to melt in your mouth with every bite. To achieve this, the mixture undergoes constant monitoring. Operators, with the help of measuring equipment, supervise its temperature, humidity, and viscosity in real time, ensuring that each batch always maintains the same smoothness and characteristic flavor. When the cream reaches the ideal consistency, it is stored in temperature-controlled refrigerated tanks, where it remains ready and waiting for the most anticipated moment of the entire process, being placed between two cookies to create the definitive Oreo. Step 5. Assembling the Oreo. On the huge automated lines, thousands of cookie discs move in an orderly fashion on conveyor belts. First, a machine places the bottom bases in a row, aligned with total precision. In parallel, another belt prepares the top lids, which will soon crown the final product. In the center, a high-precision dosing system deposits the exact amount of white cream on each base. There is no room for error here. Too much filling would break the balance, and too little would ruin the consumer's experience. For this reason, each injection is calculated to the gram, forming a perfect disc of smooth, bright cream. Immediately afterward, the top cookie is placed on top, applying just the right amount of pressure. Not too much, which could break the disc, and not too little, which would cause the cream to overflow. The result is the perfect sandwich: cookie, cream, cookie. A balance so perfect that it has remained unchanged for over 100 years. The speed is impressive. In just 5 minutes, a single line can assemble tens of thousands of Oreos, while high-speed optical sensors and cameras begin an initial check, supervising the assembly of each unit. If any minimal fault is detected, such as a misplaced lid or poorly centered cream, the system automatically discards the cookie, thus maintaining the brand's quality standards. Finally, the result is the product we all know: millions of perfectly identical Oreos ready to move on to one of the final steps of the process. Step 6. Final quality control. In a production of this magnitude, it is not enough to just assemble millions of cookies. Each Oreo must be perfect. Once formed, the cookies move on conveyor belts to the final automated inspection area. There, high-speed camera systems and optical sensors check each unit one by one, verifying the exact weight of the cookie, the shape of the disc, the uniformity of the stamping, the color of the bake, and the correct amount of cream. But not everything depends on machines. Specialized operators select random batches and subject them to manual tests, checking the texture, flavor, and aroma of the freshly produced cookies. This dual control, human and automated, ensures that only the units that meet the highest standards move on to the next step. Step 7. packaging, and global distribution. After passing all the controls, the Oreos are ready for their final great journey: packaging. The cookies move on belts to high-speed packaging machines, which organize each unit in the exact position before being packaged. Depending on the format, they can be grouped into individual, family, or multi-packs, always maintaining the same standard of freshness. An automated system places the cookies in their typical aluminized plastic wrappers, a material designed to protect them from moisture, air, and light, ensuring they stay crunchy and with all their flavor intact for months. The sealing is airtight and is done in fractions of a second, ensuring that no package is left open or poorly sealed. Next, the finished packages go to automated packaging equipment, where robotic arms group them into large cardboard boxes, which are then stacked on pallets and stored in gigantic distribution centers. Finally, refrigerated trucks and maritime containers transport the cookies to supermarkets, stores, and gas stations around the world. It is estimated that the annual production of Oreos is so large that if they were placed one after another, they could circle the entire planet up to 3 times. This is another example of the brutal impact and gigantic scale behind the production of these cookies. To finish, tell us, did you imagine this whole process? What is your favorite type of Oreo? Leave us your answer in the comments, and if you like this video, don't forget to like, subscribe, and hit the bell so you don't miss the next factory tour.